In the last video, we understood what is a modulus, conjugate, and we also solved a couple of problems, isn't it? Now, there are certain properties of conjugate and there are certain things what you need to do to understand how a multiplicative inverse of a complex number can be calculated. So, there are certain properties. Okay, before we start with the next set of questions, you guys need to know this. See, what you know, suppose say you have, z is equal to a plus ib. You know that this is the general form of a complex number. Whenever we talk about conjugate of a complex number, you have z bar is equal to a minus ib. This also we had discussed. Alright. Now, what are the properties we have for a conjugate of a complex number? That's what we are trying to look at it. Fair enough? The first property, it's a very simple property. Suppose if you have, say, z1 and z2, these are two complex numbers, and you're going to talk about the conjugate of them. In the sense, say z1 bar and z2 bar. These two are the conjugates of the complex numbers z1 and z2. Alright. Now what we have is that suppose if you have z1 into z2 whole conjugate, this becomes z1 conjugate into z2 conjugate. This is one of the properties. It's a very simple property. Okay, the next property what you have, z1 divided by z2, the whole thing conjugate if you take. The whole thing conjugate, okay? This becomes z1 conjugate divided by z2 conjugate, provided z2 conjugate is not equal to 0. And I think it's quite obvious that why it should not be 0. The third property for conjugate is that suppose say you have z1 plus or minus z2 whole conjugate, the whole conjugate. This becomes z1 conjugate plus or minus z2 conjugate. Now, these are three properties for conjugate. Okay. Now, there are same thing for modulus also. Modulus, do you remember? See, modulus again, we'll look into that also. What you have is that suppose say we are talking about the modulus. See, in modulus, z is equal to a plus ib. So, mod of z is equal to root of a square plus b square. Correct? This is what we mean by modulus. Now, modulus also there are three important properties. So, the first property is about, suppose if you are having modulus of z1 into z2, this you can very easily write it as mod of z1 into mod of z2. Okay, this is the first property. The second property you have is that suppose if you have mod of z1 divided by z2, this becomes mod z1 divided by mod of z2, again provided mod z2 is not equal to 0. Okay. Now that you have understood the properties of conjugate and modulus, see, can I relate or is there any relation between modulus of a complex number and conjugate of a complex number? We'll look into this one. So, is there any is there any relation or something like this one? Okay, let's try to find the relation between these two. That is, we are talking about the conjugate, which is on the left side, and modulus, which is on the right side. Okay, let's try to derive one simple formula. For the formula, very simple. Let's take z is equal to a plus ib. Fair enough? So, z bar is equal to a minus I into b. Now, let's multiply these two. In the sense, you do z into z bar, the conjugate. This becomes a plus ib into a minus ib. This becomes a square minus I square into b square. But I square is minus 1. This becomes a square plus b square. This is equal to z into conjugate of the z. What is the modulus formula? Modulus is nothing but mod of z is equal to root of a square plus b square, correct? Look at the RHS, it's just a square plus b square. So what we can write from this is that z into z conjugate is equal to mod of z whole square. Now this is a very important identity what you can think of. And this is the relation between the conjugate of a complex number and modulus of a complex number. Now why this is important? Because we try to calculate the inverse of a complex number. Okay, one example, suppose if I ask you, so see here I'll tell you that z is equal to say 2 plus 3i. What is the multiplicative inverse of this complex number? Okay, of this complex number 2 plus 3i. So multiplicative inverse, z inverse is equal to what? 1 divided by z, correct? 1 over z. Here whenever you have 1 over z, it's basically 1 by 2 plus 3i. Here we multiply and divide by the conjugate. So that means you are multiplying the complex number with the conjugate. So you are basically doing z into z conjugate, which will give you mod of z whole square. In the sense here we are doing 2 minus 3i, 2 minus 3i. Numerator becomes 2 minus 3i divided by the next one. This becomes 4 because 2 square is 4. This is a square minus b square formula, right? So minus 3 square I square, which becomes plus 9. Or this becomes 2 minus 3i divided by 13. So this is z inverse, isn't it? Z inverse, or the same formula z inverse is equal to z bar divided by mod of z whole square. This also you can use as the formula. Okay, z inverse. Don't you think this is the same as the previous formula? Because look at this, you have z value. You have z value, correct? You might as well write this as 1 by z inverse. And if you transpose, you are going to get the same value whatever we have done on the right side. Okay. So this is the way how you calculate the multiplicative inverse. And if you just go back on the video, you will figure out the properties of conjugate and modulus of a complex number. In the next video, we'll solve few problems based on finding the multiplicative inverse of a complex number.